So for our second and final lecture of the day, I'm going to talk about climate change challenges to agriculture, food security, and health. And I want to acknowledge my co-author of this presentation, Daniel Hillel, who was one of the also really shining lights of agriculture scientists and a world, that's right, David's of course, is that Daniel Hillel received the World Food Prize for his work on drip irrigation, the science behind drip irrigation, contributing to that, and also his very early work on realizing that the climate change that was projected, the climate changes early on were coming out of the projections of the global climate models would definitely challenge the world food supply. So we're going to launch in to an overview of climate change and the food system. So for a long time, researchers who were studying climate change and food focused, let's see, and can I get a, oh yes, I'm going to use the arrow, really were focused on the supply side. And a lot of the work continues to be done, focus on what will happen to crops, what will happen to livestock. But in the past few years, really, the context in which climate change is considered for food has expanded dramatically, and it's now really expanded to what's known as the food system approach. So this is expanding the blinders and looking, for example, not just at the supply side on the agriculture side, okay, what will happen to the supply of crops and livestock, for example, but what about the people who are consuming the food and their food security? So this, of course, increases the systems that we need to include in the studies. It makes it a lot more complicated if you're just for a long time, we just looked at, okay, what's happening to the climate scenarios and the effects on, let's say, maize in Iowa, right? Or corn or maize, corn as we call it in the United States, and maize internationally in Iowa. But really, to take this much larger food system approach, we need to understand what's going on in terms of the biological systems, what's happening to the nutrients, what's happening to the waste flows. Oh, here's our climate system, by the way, greenhouse gases, which of course have an effect on supply and demand, and then also agriculture, as we'll show later, of course, is a producer of greenhouse gases as well. But, you know, agriculture is not just a biophysical system. Just this side, it's a biophysical system, but it is really a big part also to understand, relies on the economics and social system as well. So actually, from the beginning, I enlisted, I'm an agronomist by training, but we realized that since agriculture is a livelihood for approximately 1 billion people on the planet, that to really understand climate impacts and climate change impacts, we have to bring in economics and of course the social system as well, not just economics. So, and this has to do with the incomes and the livelihoods of those 1 billion people and how that affects food security. And then, of course, final one is, well, you know, all of this is affected by the political system in which, for example, subsidies are created to grow certain crops or to perhaps privilege some types of agriculture over others, and that the political system is key to the food system approach as well. So you can see that things got a lot more complicated than beyond. Things are a lot more complicated now in terms of climate change in research on agriculture. So let's go on to explore the concept of food security. So again, you see up here in this corner, here's our food availability. All of the work, I think, was focused on this for a long time. But really, with contributions from FAO and others, and Amartya Sen at Harvard, there is now a realization that to have food security for all people at all times around the planet, you need to have a lot more than just the sufficient quantity of food. Of course, you have to have that. If you don't have the sufficient quantity of food, then of course you don't have food security. But there are other aspects of what as well. So one is also that food has to be of the appropriate quality. And the nutrients are becoming very important, and the effects of CO2 and climate scenarios on the nutrient quality of food is a very, very hot topic of research right now. So what are the other aspects that have to be in place for a person or a family, a household, or a community, or a country to have food security? So the next one is, the next aspect or attribute of food security is food access. So you could have all the availability in the world, but if people do not have the wherewithal to either buy it or receive it, whoops, let me admit, they will not be able to acquire appropriate foods for a nutritious diet. So that food access is extremely important. It's like a right, you can think of that as almost a right to food. Everyone has to have an equal right to food, and an adequate and sufficient right to food. Now, the next thing is about utilization. So we have all our, let's say we have access to food and availability, but wait a minute. If we don't have clean water to cook it, if we don't have sanitation and healthcare to be healthy, if we don't have the adequate nutrients and adequate diets, we won't be in the state of nutrient well-being where all physiological needs are met. And when we come to the next slide, you're going to see that there are some major, major problems in the world food system arising from this particular aspect. The final one is stability. And here's one that that climate change has a big effect on, as well as food availability. Climate change can affect access and livelihoods and utilization as well in terms of clean water, but especially the food availability and the stability, because if you only have food, let's say 3 months a year, and you don't have a stable supply, that's, you have, let's say, all that you need for a few months a year, but you don't have it in a stable way, you're not going to be food secure. So this is the access to adequate food at all times by a population, household, or individual, and that no group should risk losing access to food as a consequence of sudden shocks. And so with the potential for climate change to increase the intensity and frequency of at least some of the key climate variables, this one is strongly linked to climate and climate change. Let's see which one is the best way to click. Great. So we mentioned about the nutrition and health aspects. And these two maps are showing the two major forms of malnutrition. One is hunger in the world, And this one is the one that for a long time people were very focused on this, undernutrition, the state of undernutrition. Now these numbers there are new numbers that have just actually recently come out, and the state of food security by the FAO. Since the book has been published, these numbers are updated. But the general trends in general are similar as they are updated. So there was lots of focus on hunger and undernutrition. That's what we see in the top left. But now we have almost the mirror image of that map, in which we have another form of malnutrition, which is obesity. It is now seen as one of the most important public health problems today. And the obesity is linked to diets that are very high in carbohydrates and without enough nutrients. So many developing countries and the people there, as they go through what's known as the nutrition transition, are able to buy more food, but there is not healthy food to actually buy. And what's interesting is there's almost mirror images of each other, not completely. But what these two maps, I think, are showing, and I think there's a growing realization among many, many people in the food system research community, not just the climate change part, is that the world food system is out of whack. How can it be, with the tremendous advances in agronomy, in trade, in technology around food, that we still have this major prevalence of hunger, which continues to be with us, although there has been some progress in that, and the growing prevalence of obesity. So then I mentioned about the stability, and now enter the scene of food price spikes. This is what, for a long time, there basically was, you could see prices. So this is showing commodity food price index, raw materials, and fuel prices and energy prices, which have are very important for the agricultural production. For a long time, those were really quite steady, the annual commodity price indices, like looking from 92 onwards. And then really it came really quite as a shock in May of 2008 to have the major price spikes. And in terms of previous to this, since World War II, agricultural commodity prices very often had been declining. So this gave, and then there was a further one in further price spikes in 2012. So these are multi-factored. They are not primarily, you can't just say it's definitely, you can't say it's climate change. There are a number of factors that contribute to these kinds of spikes, but climate variability and climate extreme events can contribute to these kinds of spikes. And other factors are, some had to do with energy prices going up, and that does then affect the prices of commodities. There was also things going on in the speculative markets. There were speculators who also had an effect. But this gave the world food community a big wake-up call that there could be these price spikes. And as a consequence to these, there were food riots in over 30 countries of the world. So we have the system becoming more volatile sort of in and of itself, as well as the potential for climate change with its increasing intensity and frequency of extreme events to pile on and influence these kinds of price spikes. So these are some examples of current climate stresses. So drought, which some of you may have experienced and probably in your own locations experienced others as well. So we see effective drought in Texas. This is August 2013. We see the very, very long drought in California. That's the accumulated precipitation deficit, 2012 to 2014. On the other side, flooding in Myanmar, 2015. Pakistan wiped out the harvest in August 2015. So not every event is linked, can be attributed to the kind of forcing that David was talking about earlier. In some cases it can be, and these extreme events are beginning in some cases to be able to be attributed to have an influence from the changing climate forcing. Certainly the projections coming out of the models are showing the potential for increased extreme events, as David said, just on the flooding side, because warmer air can hold more water vapor. The potential for increasing heavy downpours is definitely increasing, and certainly in some places in the world, including right here in the Northeast, we've had a 70% increase in our heavy rainfall since, I think it's from about the 1970s. So these are the kinds of things that affect large-scale regional agriculture. You can see that it happens in both, not just in the developing world, but in the developed world as well. So when we go to study and do research about climate change in agriculture, it's multiple factors, very similar to what David was describing with the salinity, the evaporation. So there are some potential benefits. So some of them are that just in general CO2 increases the carbohydrate production. There's a big caveat about that now, because new work has come out that that the nutrients may be some data in a little while on that, but that CO2 does fertilize, increases photosynthesis. Warmer temperatures also increase, could cause longer growing seasons in places where agriculture is constrained by colder temperatures, let's say up mountains and in higher latitudes. It can make a longer growing season. And in some places where there's a lot of places in the world that are dry, if there is the potential for increased precipitation, which is result in some of the places and regions in the models, that can be helpful to crop production. But at the same time, there are possible drawbacks. So there are more potential for more frequent droughts because of that increased evaporative demand. There is the potential for heat stress on the crops during key growth periods. There's the potential for increased pests and diseases, and I'm going to show some data on what's happening already in that regard. And then for annual crops, that it actually shortens the growing period, and therefore doesn't allow as much time for carbohydrate, for example, or protein to be created by the plants, so that there's a negative pressure due to the growth, hurrying the plants through their growth stages. And then in several places in the world, there are major agricultural regions where there can be increased flooding and salinization. So when we go to study all these things and have the effects, in a kind of similar way, we need tools that are going to be able to help us understand what's going on with these different processes. And so one of the tools, and the one that I've used the most, are dynamic process crop growth models, which in some ways are a bit analogous to the global climate models because they're process-based, and we use them to really explore processes, just as David showed with the global climate model. So for a long time, people researchers, we did just one or two crop models and one or two climate change scenarios, and it was hard to then express the uncertainty around what the models were saying in any rigorous way. So we, with colleagues, agricultural modelers around the world, we founded the Agricultural Model Intercomparison and Improvement Project to try to work on improving the rigor by which modeling studies in agricultural impact can be done. So one of the first things that AgMIP did was found the wheat model intercomparison team. It's one of the leaders is Santos and Frank Evert are some of the other leaders. And we thought when we started that there would be maybe 5 to 10 wheat models around the world. And lo and behold, 27 wheat models came out of the woodwork. So, which is great. And now I think we're up to maybe in the 30s. So what we do in AgMIP is we create protocols. It's very similar to the CMIP, Climate Model Intercomparison Project, in which protocols are developed by the modelers themselves to compare their models in a rigorous way. And what this allows is the characterization of uncertainty across the models in a rigorous way. So, and then what we also do is we test the models in different locations. So in the Netherlands, India, Argentina, and Australia, we had observed data. They collected experimental data from the fields and then gave some of the data to all the modeling groups, plus the climate change scenarios based on GCM projections, similar to some of what David was showing. And then what we can do is say, well, what we can compare what the temperature effects were compared to the CO2. And we can see, this helps to understand, again, the sort of balance between the different factors. So what we see very clearly is that there is a declining yields with higher temperatures. You can see all those three. Yep, here, let me, can you see all of these are, as the temperatures, these are temperatures going up and the yields are going down. And then on this part is increases in CO2. So in general, CO2 has been shown both experimentally and in modeling to be a positive factor. But remember, we have the nutrient story, which is coming up. But if you look, even with the highest levels of CO2 here, even with the higher CO2, there is the potential for significant yield declines due to temperature, even with high CO2. So the high CO2 is definitely, and more, being shown not to be a panacea for the crop productivity. That's really what we've learned. And this is the this is the article in Nature Climate Change, which describes in detail that those results. Now, of course, temperature is not the only thing that that crops need. And of course, the crops need water, either through precipitation or irrigation. We know, as we mentioned, drought stress affects yields, particularly during critical growth periods. At the same time, remember we saw those pictures of the floods. Excess water can be just as damaging to the crops as the droughts, actually, because crops do not, there's an agronomic expression, crops don't like to get their feet wet. And it causes waterlogging, lack of, takes, clogs up, the crops can't get oxygen. So, but what the graph is showing is maximum grain yield plotted as a function of the amount of transferable water. This is from Thompson Clare, available through the growing season. And then two environments are shown, and the C3 and the C4, which are the two important photosynthetic pathways. And so when we think about how, as water stress increases in some regions, the C4 crops, and this is such as corn or maize and sorghum, these were favored in both of the environments. So the potential for crop shifting, crop zonation shifting, and since there are no dumb farmers, you know, farmers will and already are in many parts of the world where changes are already occurring, are beginning to make these kinds of shifts. So then, of course, the effects on soils, another important part of the agroecosystem. This is from Angela Kang, who did a NASA postdoc with us. And, you know, there's lots of work done on the carbon cycle of the entire Earth system. But, you know, the carbon cycling is very much a key part of agroecosystems as well. As we can see, the photosynthesis, we talked about that, then soil organic carbon, mineralization, release to the atmosphere, and then recycling of crop and animal residues, and then of course some of it taken off for consumption. So as we think about this role of the carbon cycle and the consumption, and we're beginning to start thinking about the role of diet. That right now we have lots, there's lots, in many places in the world, there has been, especially in the developed countries, production of taking over the big, what's known as the big four: corn, wheat, soybeans, and rice. And then a lot of this is used, a lot of the products are then used to raise livestock, which have also health problems of their own in terms of diet, and is potentially also through their manure also emitting greenhouse gases of their own. So there's now really beginning to be a consideration of the potential for changing diets to be a contribution to the solution of climate change. So it's really very exciting that I would say this realization is beginning to grow. Of course, there's all different soil regions all over the world, and high temperature effects. Also, when we think about this, it's going to be affected as the climate changes, because high temperature effects on soil, biological and chemical processes are very real. And we mentioned the heavy downpours, of course, from the increase precip. I mentioned about the pests and diseases. So the changes in climate and extreme events could have significant effects on the damage caused by and location of agricultural pests and diseases. And these are showing some data from Spain, actually, with 4 different pests and diseases of potato. And each one of these is showing, this is over the period like 1952, like to 2010, I think, that the time of first appearance of these 4 insect species was earlier every year, responding to the warming. So, okay, it's earlier, more pests are appearing earlier, more damage on the crops. So it's hard. This is one of the hardest things to predict in terms of, and in fact, we were just asked this at a recent, we were just talking about this at a recent IPCC meeting about, well, can't you say which regions are going to be affected by changes in disease and insects and diseases for crops and livestock? And in fact, it's actually very hard to. because again, it's multifactored. It's part of the agro ecosystem. What about the predators? You can't just look at one. Really do quite a complex analysis. But that being said, virtually all studies, or almost all studies, I would say, have found this statement to be true, that there could be significant effects on the damage. And AgMIP now has several teams of agricultural entomologists working on doing whatever, improving the modeling as much as possible so that preparations for the pests can occur. So again, putting the models, the crop models together, and the climate models together, that's what these maps are showing from a paper that was published in PNAS in 2013. And this was, I think, the first paper that ever showed a rigorous protocol-based projection. So there have been lots of projections of what would happen globally, but this is the first one that used 7 global gridded crop models and 5 global gridded models in AgMIP protocols. This was the agricultural contribution to EasyMIP, which is led out of PIC in Germany, and this is under RCP 8.5. And you see these hatch marks. I know it's a little bit hard to see, but these hatch marks are the very first time that the model uncertainty, model agreement, and model uncertainty was ever shown in a projection of how climate change would affect the global crops. The result that was found is not that different to what had been found before, but it's that and that is very, very significantly that the lower latitudes are more vulnerable to climate changes, in particular for maize and wheat. Perhaps less so for rice and soy, but these are also less ubiquitous. But you can see this basically a band of across the low latitudes of the potential for high levels. 8.5 is the high, it's basically the business as usual scenario that we're in. We call it the high emissions, but it's the one that we're actually in, to have a very strong downward pressure on these major crops. Now, AgMIP also from the beginning has included economic models as well. So this is 9 global economic models, and using some of the results that I just showed in the previous crop modeling protocols to look at what would happen to agricultural prices. So if we think that there's a lot of uncertainty in the climate side and the crop side, David, think about, look, these are the uncertainties across the 9 global economic models. However, what we can say is very strong potential for upward increases, upward pressure on agricultural prices. And it was just great when we would have AgMIP meetings and the global econ modelers get together, and you know, and part of it is not, I'm sure you feel this, utilizing the models too, so that questions can be asked, and so that each group can improve their own models. Say, oh yeah, how did you do this process? And that's what they would be asking each other. And from that, the whole enterprise of modeling, I think, gets to be improved. So this is the potential for large price increases with climate change, although uncertainty is also large. It also perhaps harkens back a little bit to those price spikes that we saw and the potential for them. Now, I mentioned this set of new work that came out about the effects of climate change and CO2 And this is on so the first one looks at and the calories and the iron content of the crops that were tested. Then the scenario was tested with climate change scenarios, and the production decreased. That's what this red is. So that then the amount, there's a calorie production gap, as we just saw, that there would be a net negative effect on the production of calories. Then the next and final scenario that was tested was to add in the CO2 fertilization effects and climate change. So you see that CO2 helps on the calories, right? So this red is lower, but because there's now known effects of high CO2 on iron, zinc, and protein, we've recovered some of our production, but the production that we have is less nutritious. And this is clearly a very, very critical point as we go to really try to deal with climate change in the food system. Okay, change hats. That was all about the impacts of climate change on the food system. But we also have to put on a different hat because the food system itself is a major contributor of greenhouse gas emissions. So these are from, this was from 2013. Again, all these numbers have been updated, but this gives the general idea. So we have a lot of sources of these greenhouse gases from agriculture. The most important one, of course, is here, the enteric fermentation. That's from livestock that are ruminants and are creating methane and releasing methane as part of their digestive process. And so this is what I was saying in that earlier carbon cycle of the agroecosystem. The role of livestock is very, very important. And therefore, this trend of increasing meat consumption and therefore increasing meat production has a very important feedback effect onto climate change itself. So that's by far the biggest one, but there's also the other ones: manure left on the pasture, rice cultivation also produces methane, synthetic fertilizers, the production of synthetic fertilizers creates greenhouse gases, manure management also, and other. So this is again, rule of thumb, that the total of greenhouse gases from agriculture is about 14%, but if you add in the clearing of land and natural ecosystems for agriculture, that can add about 12%. And so altogether, there's about 25% from agriculture. So after the energy and fossil fuel, and all the utilities, electrical generation, and all of those fossil fuel sector, really agriculture is the next biggest one. So when we think about both the impacts and also the solutions, we clearly have to there's a huge role for agriculture to play. So what are some of these solutions? These are just some of them. Soil carbon sequestration, we mentioned that as well. There is the potential of sequestering carbon at a cost competitive with other methods of reducing atmospheric greenhouse gas concentrations, because when fields have been pastures, let's say, or have been plowed up, or natural ecosystems, then it loses the carbon. And with practices, it is possible, quite challenging, but it's still challenging to do that, but it is possible to sequester some of the carbon. Biomass carbon sequestration, this is with agroforestry that can play quite a large role in the carbon sequestration and mitigating CO2 emissions. And then, of course, last but not least, the potential for biofuels. So this is, with the exception of ethanol made from corn, which is actually very hard to actually get a net a net savings in greenhouse gas emissions. It has been shown that that there are systems of biomass which can produce heat, power, or fuels to result in zero or close to zero CO2 emissions. So there's lots, but then of course you have to be careful because it can't be competing with food production. So the biofuels is quite challenging, but these are some of the potential within agriculture to mitigate climate change. Okay, now that was on the mitigation side, but meanwhile, with the climate changing, it's already changing, we have to adapt and become more resilient. So this is a slide that shows the progressive levels of adaptation and some of the challenges and opportunities. So, and this is from Mark Howden in Australia. So, you know, right now, as we talked about, varieties can change, planting times can change, row spacing, and then the management of the residues, the water, the nutrients, and the canopies can change. So this is basically adaptation level 1. But as climate change continues and the changes in the regions get to be greater, more interventions will likely be needed, such as production change approaches. So this means maybe we utilize more processing either in the field or away from that particular region. We can find climate change ready germplasm, and we can do diversification, and farmers can do diversification and risk management. So this is like a second tier of levels of adaptation. But as the climate change progresses, eventually agricultural regions may need to change their land use and have real transformation and develop new products such as ecosystem services, such as carbon sequestration, such as offsets in agroforestry, for example, to supplement. But of course, we also have to be sure we have healthy food for the food security of everyone on the planet. But so this sense, and so some of these things some things are happening already. Certainly in the tier 1. This is the crop breeders are of course working on the climate change ready germplasm. Some of that's already in place. This idea of diversification is very interesting. In some cases, this diversifying has been shown to be a very good, basically, risk management against those increasing extremes. But eventually, we're going to have to, I think in many places around the world, I think the agricultural systems and the agro-ecosystems will need to change. And it may be supply driven and also demand driven as well with the diets. There's the potential as we go up though, increasing complexity, cost, and risk. And so how do we get everyone to change their diets? It's if we're going to be having that be one of our major transformations. It's very challenging. Okay, coming now to just the last couple of slides. This is about a big project that we did in West Africa, and we did it in several regions in Africa, working with teams of agricultural scientists and economists there, and using the crop models with adaptation packages, testing with and without adaptation. And what you can see here is, this is income, millet, maize, peanut. This was without adaptation, with a range of adaptation packages that the farming system was able to adapt. In particular, not so much with the maize. There was like still the potential for decreases, but the peanut, the agricultural team we worked with were really quite excited about the potential for peanut to be a marketable crop that they could use. And so this was done with regional economists as well. What they showed was, so it's not only what's happening, here's the biophysical part, but also with the income as well, that these adaptation packages can raise incomes, lower poverty rates, but do not always compensate completely. But you know, a lot of times with Africa, it's been very gloom and doom scenario. But what we find is when we go in with a much more nuanced set of models, scenarios, adaptations, and the economics of it, it's of course still a negative pressure, but not in we certainly in every place didn't find once you add in the adaptation, that you know, there's still, I would say, reasons for hope to be able to at least compensate at least in part. This is the last slide for, and then just before the conclusions. So what AgRIP has done through now, through its development, we realized that we had the tools with AgMIP to coordinate both global and regional assessments of agriculture and food security. And this is also something that really hadn't ever been done before, I don't think. So we just talked about West Africa, and the work that we do is with RRT stands for Regional Research Teams, looking at farming systems with biophysical and socioeconomic models. So we have teams right on the ground testing scenarios and adaptation packages. Then remember, we also looked at the global modeling. Remember, we were looking at the global modeling, and we have the global modelers. And we have the global economics. I showed their results. And we have the regional economics as well. So what we realized was, and we held an Aspen Global Change Research Institute workshop to actually create protocols. So for the first time, the global modelers could get hooked up with the regional modelers. Because, David, as you know, the global modelers is a very high level kind of bird's eye view approach. And really, for something like agriculture, agriculture doesn't actually exist unless it's on the ground. And so we developed protocols in which we passed results from the region to the, from the regional modeling to the global modeling, and we passed results, for example, prices, when there are regions that take prices from the global markets, and we put those into the regional mix. And we also then could compare, reality check, well, what did we get, for example, in the crop modeling in Western Africa compared to what did the grid box get? It's very similar to, you know, work that we're doing right now to really do ground truthing and bring the scales together. So, and this actually, since this book went to press, this has now several papers have been published on this. So the goal of this, we call it CGRA, is to significantly improve understanding of climate change impacts on agriculture, food security, and health. So here are the conclusions. Farmers are faced with the quadruple task of reducing greenhouse gas emissions, coping with an already changing climate, delivering healthy, nutritious food, at the same time as sustainably managing soil and water resources. So we're coming back to agriculture, not the whole food system, but in terms of agriculture itself, it is really called upon to ensure both human and planetary health. And I want to end by thanking David for such a wonderful collegiality all through the years. Thank you, David. Okay, we do have a bit of time for questions and comments, and I'm happy to launch in.
Yep. So once again, if you have questions, you can either go to the participants tab and open it up and click raise your hand, and we can click on you and you can ask the question verbally, or you can head on over to the Zoom group chat and type in your question there. We're monitoring the chat to see if there are any questions for Cynthia or for David again, or for any questions about the series itself.
I think some of it, is an artifact of the global grid, of the global gridded crop models that we used, and that they were not ubiquitous in not having a big enough effect in the grid box. I think that there are still. Oh, okay. I think that there are still there are still high temperature impacts on rice, although, and we have, by the way, in AgMIP, we have, just as we had, I showed the wheat team results, we have a rice team as well, and they're working on those things in particular. But I think it's actually an artifact of the amount in the grid box of production. Yes. So in the work that I showed, actually, maybe we can go back. Let's see. Can we make it up? In the work that we developed in the West Africa and all of Africa and South Asia, we worked with the economists on new protocols that actually also, for the first time, advanced the technology. Because again, most of the work was always done with the current technology. And so you were sort of marching into the future in climate, but you weren't taking into account that agricultural technology would increase. So it would be advancing. So the way that we did it was each of our teams met with the local stakeholders and local experts, and they went through a process to create something that AgMIP calls RAPS, and it stands for Representative Agricultural Pathways. And it actually goes through and brainstorms. Of course, you never know exactly, but it brainstorms on what will be fertilizer rates, what will be changes that will be occurring in that region, in that agroecosystem, regardless of what happens to climate. And so then when we go to the climate change, we do it, first of all, we do it in the same way that everybody did it for a long time, but then we advance the system into the future and we apply the climate change scenarios to that. And so, of course, what it does is, that's one of the reasons. Remember I mentioned that what we were finding was not, we were finding not as severe impacts, for example. Well, part of it is because nobody had ever said, oh, Africa's not going to stand still. Agriculture in Africa is not going to stand still. It's going to be advancing. And so then the climate change impacts they're still significant, but they're not as severe. Okay, that's Danielle. And now I want to introduce and thank Danielle Manley, who's here, one of our editors. And Danielle is helping to win with the book speed.
Hi, everybody. So Claire is one of the authors of one of the chapters of this book. First of all, again, and I also want to thank both Cynthia and David for their hard work in this and for the great presentation today. And Claire, thank you for that as well. Claire, you'll be receiving your copy soon. We are mailing them out in the next couple of weeks. So keep an eye out in the mail. Then our second question is again from Dr. Ravi Fernando. And Dr. Ravi Fernando says, most southern atmospheric nations are projected to experience significant water scarcity. If we persist with mass agriculture, this could be a major challenge. Is moving to precision agriculture, as Holland and Israel have done, where water use is 10% versus mass agriculture and has increased yields of 4 to 7, an option?
The answer is, thank you, Dr. Fernanda, for this question, which is a very good one. The answer is very simply yes. Because of the challenges, and I'm looking at David because of, what those regional maps of water resources look like. And there are some areas which have increases, but some are projected to decrease. So those places, the techniques of such as precision agriculture, there's also climate smart agriculture, which is bringing in not only on the adaptation side, but also on the reduction and mitigation side. So there are many technologies that are available to be used to deal with this major challenge, which will be water resources in some regions. The other thing I would say that's coming out more and more is this, which I mentioned, was this idea of the role of, well, what's being grown and what's being eaten. And the idea that the world food system may really shift and may need to shift as the climate changes. I think this is a discussion that we all need to have, and probably sooner rather than later.
Well, thank you, Cynthia, for a very digestible talk. However,
Thank you, David. So I think Danielle, can we wrap up? I think so. All right, when is our next one?
So thank you everyone for attending today's webinar. As we said at the beginning, but for those of you who have missed it, this is part of a monthly webinar series that we are starting today. So our next webinar is going to be on October 16th at the same time, 4 p.m. Eastern New York City time. And we're going to have 2 lectures. The first is going to be from Judith Lean, and the topic is on global change in the Earth's atmosphere, natural and anthropogenic factors. And the second webinar is going to be on by Gary Russell, and it's on building a climate model. So again, we're running these monthly from now through July of 2019. we'll be sending out, and today's lectures are being recorded, and we're going to make them available online on the Consortium for Climate Risk in the Urban Northeast website. We'll be sending out a link to that as well. Yeah, we're really excited. So be on the lookout for the next in the series, October 16th. And thank you everyone again today. And thank you to Cynthia and David for their great presentations today.
Thank you.
Great. And with that, we will conclude the webinar. Have a great day, everybody.